Hey everyone, in this video we will understand about the one of the disk scheduling algorithm, that is first come first serve. So before this, let me tell you that I have made a full playlist of the operating system. You can find it on my channel, and along with that you can find the other playlist of the various other computer science topics. You can find it on my channel. Okay, so do watch them. So let's start. So in the previous video we have already discussed what is disk scheduling and why do we need actually the disk scheduling and what are the different type of disk scheduling algorithm. Okay, we have read the names of those different type of algorithm. So basically we understood that your hard disk controller, it might be busy servicing some of the request. Okay, let's say it is servicing the request, let's say R1. So let's say a request R2 come. Okay, so when it comes, then it may not be serviced at the same time because controller is busy in servicing R1. The same way the any other request R3, it will have to wait. Okay, the same way R4, R5, all the other requests, they will have to wait. Okay, so that later on they can get their time on this hard disk and their data can be read or written on this hard disk. Okay, so basically all these requests, they are waiting in this request queue, okay, which is handled by this controller. Okay, and operating system will put the request in this queue and the controller will pick the request one by one from here. It will take it to the hard disk. Okay, and then the data will be read or written. So basically we have to select the request from this request queue in such a way so that we can minimize the seek time. Okay, so basically what is seek time? We have already discussed. Seek time is the time it takes for the read write head to move to the desired track, right? Basically seek time is greater than rotational latency. So all the algorithms that we are going to discuss, which will be able to select the you can say request from this request queue, their main motive will be they have to decrease the or reduce the seek time. Okay, because it is larger and it actually governs the access time. Okay, if seek time is smaller, the access time will be you can say lesser and it will be faster access time, right? Your data will be read or written in lesser amount of time. So what are the different algorithms we can use in selecting these requests, that which request should be selected first? Either R2 should be selected first or R3 should be selected, then R4, then R5. Okay, in which order the things should be selected? This answer is given by our disk scheduling algorithm, right? So what are the different type of disk scheduling algorithms? So these are the different type of disk scheduling algorithms. First come first serve, shortest seek time first. Okay, scan, scan, look, and look. Okay, C stands for the circular. Okay, so basically we have understood the format of the input output request which can come to the hard disk, right? So basically it can have platter number, then surface number, okay, then you can say track or the cylinder number, and then sector number, right? But as I have told you in the last video that your request queue will not contain all these four things. Basically it will contain only the track number or the cylinder numbers. Okay, so this is like 98 track, okay, or 98 cylinder number. This is the 183th track. Okay, this is the 37th track. Okay, so request will be stored in the form of cylinder number or the track number inside this request queue. Okay, and one by one these algorithms, okay, let's say we are using the first come first serve algorithm that we are going to study in this video. It will be picking the request one by one from this request queue and they will be given to the hard disk. Okay, and your data will be read or written. Okay, so basically these algorithms are there to help in choosing this you can say cylinder number or the you can say track numbers. So let's understand what is first come first serve algorithm in this video. So here you can see we have a question and the question is asking some of the things, okay, based on some data that we are given. So what is given to us? So the question is saying your hard disk has 200 cylinders. Okay, you can say this is one of the cylinder, then there will be one more cylinder, right, and so on. Okay, so this is like you will have next cylinder. Okay, then you will have again next cylinder. Okay, so let's say this is the 0th cylinder, this is the first cylinder. Okay, let's say this is the second cylinder. The same way as I have told you in the previous video. Okay, here also it will be first cylinder, then here it will be like second cylinder, and so on. Okay, then the another thing that we are given with is request queue. So request queue is containing your various request in the form of cylinders. So we want to read, or let's say write the data to the 98th cylinder, then 183, then 37. Okay, so these are the different cylinder numbers, and these will be between 0 to 199. Why? Because your hard disk contains the cylinders from 0 to 199. These are total 200 cylinders, right? Okay, and you are given that initial position of read write head is 53 cylinders. That means this is your read write head. So initially it is on 53 track. Okay, so this is the current position of read write head. Okay, so now the question is asking, you have to tell that what will be the total number of head movements. Head means this read write head movements, or what will be the total number of seeks, or you can say what will be the total number of cylinders traversed, okay, in servicing all these requests. Okay, and the second thing, find the average head movements. Okay, on an average, how many times your read write head moves, okay, in servicing all these requests. Okay, so this is the question, right? So let's say we have the 53th cylinder. The 53th cylinder is having this read write head. Okay, it is there, and now it will go to 98. Okay, then it will go to 183, and so on. Okay, so this is the thing. Okay, so now let's see how the FCFS algorithm will be applied to this question. Okay, so to solve this question, we should understand that we can just put or make a reference line, okay, which can contain either all these, you can say, cylinder numbers. Okay, and you need not to write the counting from 0 to 200. Okay, 0, 1, 2, 3, okay, till 199. You need not to draw all these, you can say, track or the cylinders. Okay, you can just put, or you can just mark these given cylinders. Okay, so let's say we just put it here. Okay, so here I have written all these cylinder numbers, okay, from 0 to 199, only the cylinders which I need. Okay, now I will draw how my cylinders will be traversed. Okay, so basically currently or initially my read write head is on the 53th cylinders, right? 53th cylinders. So I'll draw that my read write head is here. Okay, and now as the time passed, okay, I have to service all these requests. So basically first come first serve disk scheduling algorithm says that you services all these requests in the order in which they arrive in your request queue. Okay, so that means I am at 53th cylinders. Okay, so what is the first request that has been arrived inside this request queue? This is this one, that is the request for the 98th cylinder come. Okay, so this is the first request. So I will first pick this one and I will service this one. Okay, after that I'll pick 183, after that I'll pick 37, then 122, and so on. Okay, so in the same order in which they are stored inside this request queue, I'll be picking in the same order. Okay, so this is first come first serve disk scheduling algorithm. So let's see. So basically from 53 I will first go to 98 cylinder. Okay, so 53 to 98 cylinder. So where is 98 cylinder? This is this one. Okay, so basically I am going, okay, going to 98 cylinders. Okay, here. So this is the 98 cylinder. Okay, you can write here also. Okay, 53 to 98, right? Then I am going to 183th track or 183th cylinders. So basically my current position is 98 cylinders. Now I'm going to 183th track to service it. Okay, so basically I will go into the same direction. Okay, and I'll go here. Okay, this is the 183th cylinder number. Okay, now this is my current position of read write head. Now the third request is 37. So where is the 37? So 37 is here. So basically now I will move to 37th, you can say, cylinder. Okay, this is 37th cylinder. Okay, so basically why I'm drawing it like I'm going from here and then I'm going down. Okay, then I'm going again down. Why? Because this is showing me that with the passage of time, okay, as the time passes, okay, my time is going down. Okay, so you can say at 1 p.m. okay, you service 53, you service like 798, then at 2 p.m. you service 183, then at 3 p.m. you service this. Okay, so my time is increasing, okay, in this direction. Okay, That's why I'm making it in such a way. Okay. So after 37 is serviced, now I have to go to 122. Now 122 is not in this direction. This is in this direction. Here it is 122. So I'll go to 122. Okay. So this is like 122. Okay. Then I'll go to 14. Okay. Now again, it will change the direction. Okay. So 14 is here. So direction will be changed. Okay. It will be here. Now I'll service 124. 124 is again here, right? So it has again to change the direction. Okay. So you can see it will have to change direction a lot of time. Okay. 124. Now 65. Where is 65? 65 is here. Now we will go to 65, right? So 65 is actually here. You can see here. Okay. So it changes the direction from 123 to 65. Okay. In this way. Now I have to go to 67. So where is 67? 67 is here, right? So with reference to 65, my 67 is here. So it has to change the direction. So 67 is here. Okay. 67. Okay. So basically from 53, it go to 98, then 183, then it's changed the direction to 37, and then here, then here. Okay. So basically, I have to now tell that what will be the total number of head movements. How many times this head moved? Okay. From 53 to 67, total number of times. So to understand this total head movement, let's take a small example. Let's say you were initially at the 53rd track. Okay. And let's say after 53rd track, a request come, let's say of 59th track. Okay, 59th. So basically you will go to 59th, right? So basically if I count how many times this read write head move from 53 to 59, so basically it will go to 53 to 54 first, then 55, then 56, then 57, then 58, then 59, right? So basically it will go to every track. Okay. But it will only service the request of 59. Okay, it will not service the request, but it will traverse or it will pass all these tracks. So basically it move one time. Okay, then 54 to 55 second time, then third time, then fourth, then fifth, then sixth. Okay, so basically it changes how many times the tracks or the cylinders. It changes 6 times the various cylinders. Okay, 1, 2, 3, 4, 5, and then 6. 6 you got, but 59 minus 53 is also 6. Okay, so basically you can just subtract 59 minus 53, you will get 6. Okay, so 6 is the total head movement if you count just for 53 to 59, right? So same way, what you can do if you want to count the total number of head movement, what you can do, 53 and 98, you can just subtract them. Okay, so because it is like a distance, okay, distance between the 53 and 98. Okay, it is not like a displacement as you have understood in the physics. Okay, so distance cannot be negative. So it is like how many times you have moved from 53 to 98. So basically you have to just subtract bigger value minus smaller value. So 98 minus 53. Okay, this is one away, 98 minus 53. Okay, then plus you can just subtract 183 minus 98. 183 minus 98. Okay, so you moved some of the track from here to here, then you moved some of the track from here to here. Now plus you moved some of the track from 183 to 37, right? And what will be the count? 183 minus 37. Then you move from 37 to 122. So count will be 122 minus 37. Then you can subtract 122 minus 14. Then you can subtract this 123 and 14. And then you move from 124 to 65. That means you subtract 124 minus 65. And lastly, you went for 65 to 67. Basically, 67 minus 65, that is only 2 times. Okay. So now you can just add all the total head movements. Okay. You can subtract all these things. So after we add all these numbers, we get 640. Okay. So basically 98 minus 53 is 45. 183 minus 98, 85. 183 minus 37 is 146, and so on. Okay, so and when I sum up all these things, I got 640. Okay, so this means the total number of head movements will be 640 cylinders. Okay, I traverse 640 cylinders starting from 53 to 67 to service all these requests using first come first serve this scheduling algorithm. Now here one thing is to note. The thing is that while you are moving from 53 to 183, you can just make your calculation shorter. How? So 53 minus 98 is 45. 98 minus 183 is 85. So what you have to do is you can just directly do one thing. You can just see 183 minus 53. You can do this thing also instead of these two calculation. Okay, so if you subtract 183 minus 53, okay, what you will get? You will get like 3 minus 3 0, 8 minus 5 3 1, 130. And if you do 98 minus 53, 183 minus 98, that is these things, you got these things, and the sum of 45 plus 85 is also 130, right? So if you are going in one direction, you can just take the last request and the first request, and you can just subtract them. Okay, so this is like making your calculation shorter. Okay, so now last thing is we have to find the average number of head movements. Okay, on an average, how many times your read right head moves? Okay, so basically average head movement is the total number of head traversed, or total number of times your head traversed divided by the number of requests inside your request queue. Okay, so total number of cylinders, you can say traverse were 640. Okay, and what is the total number of, you can say, cylinders inside this request queue? 1 2 3 4 5 6 7 8 divided by 8. Okay, so on an average you got 80. That is, on an average 80 times your head moved to service all the requests which are coming inside this request queue using FCFS, this scheduling algorithm. And this average head movement can come in like float number also, something like 80.5 or something like that. Okay, in another numericals. Okay, but here it is like just an integer number. So I hope you have understood what is this average head movement. That is for servicing a single request, on an average how many times your head can move according to FCFS, this scheduling algorithm, if this type of, you can say, requests are present inside your request queue. Okay, so before ending this video, just to tell you that this FCFS, this scheduling algorithm is like fair. Okay, this is a fair algorithm. Why? Because in the order in which the requests are coming inside your request queue, the algorithm is just picking the request in the same manner. Okay, first 98, then 183, then 37, and so on. So there is no like biasing. Okay, we are not giving priority to anyone. Okay, we are just saying whichever request come first inside the request queue, it will be picked first. Okay, so this is like fair in that sense. Okay, and there is no starvation problem. Starvation problem is like a request, let's say, is waiting inside your request queue and its number is not coming. Okay, that means there can be no starvation, because after, let's say, these requests are fulfilled, that is 98, 183, 37, 122, 14 and 124, this 124 is service, then it is like for sure the number of 65 will always come. And after this request 65 is serviced, then it is for sure then the number of 67 will always come. It means there will be no request, okay, which will wait indefinitely. Okay, so that's why there will be no starvation in this algorithm. So this was our first come first serve, this scheduling algorithm. I hope you have understood this thing, and if you have not understood any of the point, please write down into the comment box and I will answer them. Okay, so in the next video we will understand the next algorithm, that is the shortest seek time first this scheduling algorithm. Okay, and we will see that how it is better than FCFS, this scheduling algorithm. So please like and share this video, and if you have not subscribed the channel, please subscribe the channel and press the bell icon for further notification of the videos. See you in the next video. Till then, goodbye.